If you're watching this, you probably are one of these successful students trying to make sure that their work is right for the 3-1 through 3-2 quiz. Of course, there were options where you could check your work to make sure it's right, but I wanted to talk and just make sure that you had a little bit more understanding as to how everything here worked. The first 4 problems have us using f of x equals 2x minus 6. Well, what kind of form do you think that's in? Is it linear? Is it exponential? Is it a quadratic? Is it a parabola? Hopefully you're saying this is linear because it takes on this form right here. If you check my screen, y equals mx plus b. See that? Where we have y, we have our slope next to x, and then we have our y-intercept after that. So our y-intercept in this case, pretty easy to spot. It's just going to be 0, comma -6. Reason that we're using the ordered pair is because this is an actual point that we can map out. Want to give respect to that. The x-intercept, well, there are a few ways we could approach this. We could plug in where y is 0 and solve for x, or since we have the option to graph it here, I'll show you both ways actually. I think that'll give this a little bit more life. So what I'm going to do here is graph out at -6, because that's my starting point. It's my y-intercept. I'm then going to go over 1 and then up 2 to get my next point. And I can keep that tradition going out in that direction. So notice I only need 2 points, but once I have those 2, I'm good to go. All right, so we see pretty clearly that well, what do you think? Where's the x-intercept? We already talked about this. Hopefully you're saying the x-intercept's right here. So this is the point 3, 0. Another point that's on the line, we have a plethora that we could choose from. There's this one, there's this one, this one, this one, this one. But I'll just keep it simple. I'll talk about this point here. This is 1, 4. -4, that is. If you want to check our work, this is a big key component to make sure that you're doing this right. You could check by plugging in where x is 1. You should see that 2 times 1 minus 6 should give you -4. If you do 2 times 1, that's 2. 2 minus 6 is definitely -4. -4 equals -4. Since this is a true statement, this is a point on the line. Looks good, right? Okay. Let's take this to check our work. Lo and behold, everything there is mapped out on the red line. Use this to check your work. Take it to well, what kind of equation do you think this is? It has 3, it's multiplying. Hopefully you're saying, well, in module 1, you might have called this geometric. But now you should be saying it's exponential. And if you need a refresher as to how that looks, it's usually in the form of a times b to the x power, where again, a is our starting value. B is our constant ratio. And that's pretty good to start with. So our y-intercept, well, since our exponent is just x, we can assume that we're just going to start at 0, 3. And as we can see, that's correct. Another point on the line, we'll get to that when we start to graph this out. So what I'm going to do is set up a table, get some points more organized, call this x, call this g of x, because this is a g of x function that it's noted as. I know 0, 3 is on the line. What's my common ratio here? What's my b term? We know 3 was a, so that would make 2 b. So this is saying that every time I move up 1 in the x direction, I multiply by 2 in the g of x direction. So 3 times 2 is 6. If I keep this momentum going, keep adding 1, X is 2. 6 times 2 is 12. And I could dance all day. 3, 4, 5, 6. I'll keep that going. 24, 48, 96, 192. Cool. So we got a plethora of points that you could pick from. I'll just keep it simple though, and I'll say 1/6. To check my work, I could say when X is 1, I'm taking 3 times 2 to the first power, which is really just 3 times 2, which is 6. Claiming 6 equals 6. True statement. So point's good. Let's graph this out. We can use all these points. 0, 3 is approximately in between 0 and 5, but a little bit closer to 5. 1, 6 is slightly above 5. 2, 12, slightly above 10, but closer towards the middle. 3, 24, in between 20 and 25, but closer to 25. And then 48 is way up yonder. That's about all we can get. Do your best to make this line as curved and as neat as possible. Even if you have to take a break at one of the points, that's fine. Yikes. And have this go towards 0 because it's just going to get smaller and smaller. You can check your work on the next slide. Just like that. The interval notation, talking domain, talking range, increasing, decreasing. I'm going to highlight where I see the increase. Well, there's none. So just leave it blank. Nothing's going up and to the right, so don't write anything. I see a decrease from here to here. So I'll talk about that notation shortly. I'm also going to highlight on where it's constant using purple. Okay, so I think this is helpful just to highlight on where these things are occurring. If it was happening somewhere else, highlight that too. But for now, this is okay. So in red, I know that it is decreasing from this X coordinate here, which is where X is 3, all the way up to here, where X is 9. It's covering everything in between. And so that's a good place to start. In between 3 and 9, it's decreasing. But how do you want to use intervals here? How do you want to talk about that? Hopefully you're going to use brackets because they're both closed circles. Let's see, constant, this occurs in purple from this X coordinate. And I think that's a good place to start. It's like actually find this coordinate. So I'm actually going to highlight that. So this is an X coordinate of -2, 4. This is 3, 4. I know that it's occurring between those two X values. So from -2 all the way to 3. And so let's start there from -2 to 3. I'm going to use brackets because I want to close this thing down and I want to include those values. And that's it. We're done. Talking domain, thinking on the larger aspect here, recall domain deals with X values, range deals with Y values, nothing you can't handle. I'm going to actually write down some of the questions I ask myself when I'm dealing with domain. So I'm first going to ask, what's the leftmost point in the function? That's the first thing I would ask myself. And then I would ask, what's the rightmost point in the function? Okay. So what I'm going to do is ask myself that. I know that the smallest X value, what do you think the smallest X value is? Hopefully you're saying it occurs from -2, starts there, keeps going, ends here at 9. So I know that our domain is going to be going from -2 to 9. I'm going to use brackets. call it a day. And again, I want to use brackets because it's a closed circle, but you already knew that. For the range, some questions I ask myself: what's the lowest point in the function? So the lowest being height-wise, like the farthest down. And then what's the most elevated function? And hopefully it's a continuous line and there's no breaks, because it gets a little hairy there when you're talking about those domain and ranges. So I'm going to talk about this in maroon. I see that the lowest y value occurs here at this point, this 9, 0. And I know that the function keeps rising up to the highest elevated point, which is up here. And so the y value here is 0. Up here it's 4. They're both closed circles. So that's going to be a simple one. The lowest value here was 0, goes to 4. We use brackets to close it in because it's a closed circle, and we're done. Pause this if you need it. Taking this further, talking a little bit more about this function, our minimum, state the y value. Our minimum occurs way down here. This is the lowest value where y equals 0. Notice lowest point's 9, 0, so the y value is 0. Highest, the maximum, the most elevated could occur here or anywhere in between. But in particular, it's when y is what number? Hopefully you're saying 4. And I'm right. Wonderful. X-intercept intersects the x-axis. We see that's definitely going to occur right here. So this is going to be the point 9, 0. What's cool is that the graphs, for the most part, are interactive. So you should definitely be clicking and drawing on them the same way I did. Our y-intercept occurs on the y-axis, way up here at this point, which is 0, 4. Submit it, move on with your life. Remember everything we did here. Domain deals with X, range deals with Y. Corny way to remember it. Way back when medical personnel would wear hats like these, or nurses. Corny way to remember, Dr. XY. Domain deals with X, range deals with Y. And hopefully this person will have a better day. Give them a tic-tac-toe mark. Don't forget, Dr. XY here to help you. Remember your domain and your range. Dr. XY. What do lab jackets look like? They look like this, right? Put a stethoscope on them. There you go. Boom. Dr. XY. Domain deals with X, range deals with Y. I hope that this video was helpful. If you have any questions, let me know. Thanks for watching.